Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 13 on Acids and Bases, Section 4 on Acid-Base Reaction, and this is video part 5. Today we're going to talk about buffers. And we know that buffers are solutions that resist changes in pH, and they're made of a weak acid, so an acid that doesn't totally dissociate, and its conjugate base. So let's talk about those terms just a little bit. We have here acetic acid, which we know is a weak acid. Some of it turns into H and the acetate ion, and some of it stays acetic acid. And then its conjugate base would be the acetate ion, C2H3O2, with another ion stuck on there, so like sodium acetate. And conjugate bases are the result of an acid losing its hydrogen. So if we take off this hydrogen, we're left with the acetate ion, and that when you put this in water, it's going to separate, and so you would have an acetate ion floating around, and that's the conjugate base. Why is it called that? Because you could see that bases accept hydrogens, and so if it's the acetate ion, it could accept a hydrogen. So let's look at the power of this buffer solution. It's going to resist changes in pH even if you add acids and bases. So if I have this and I add a base, this acid could donate, it has a hydrogen ready to donate to neutralize that base. So it would resist changes in pH if you add a base. But what happens if I add an acid? So this acetate ion can accept a hydrogen ion. So if I add acids, it could accept those extra hydrogen ions and neutralize them. So we see a buffer really resists changes in pH, either acidic or basic. So it's very, very functional. When do they come into play? So many places. They are important in living systems. So for instance, in your blood, the carbonic acid and the bicarbonate ion is the buffering system in your blood, which is really important for you because if your blood got between, I'll just look up the number so I don't estimate it quite wrong. Okay, your blood has to be between 7.35 and 7.45. If it goes below 7.35, you're in acidosis and your body system starts shutting down. So we really need to take care of that very quickly. So buffers in your blood system are very important. So this is carbonic acid. It can donate hydrogens, and then this is fun because it could donate a hydrogen if it needed to, or it could accept a hydrogen. And this is often the carbonic acid and bicarbonate ion is often the buffering system in oceans, rivers, and lakes, particularly in like rivers around an area with limestone, kind of like in this area, because we know limestone is calcium carbonate, and then that carbonate will mix with water and make bicarbonate ions and this. So yeah, that's a really important system for buffering the changes in pH, which is really important for living systems. Okay, you should have read pH in the environment. I would like you to write down pH of soils and plants, example hydrangeas, and be ready to tell me about that. And you should have also written down pH in aquatic life and be ready to tell me about that. All right, that concludes our Chapter 13 notes. They are done. Good job, everybody.